Welcome to this section on serverless monitoring and observability patterns. In the previous sections, we covered the implementation of many serverless microservices patterns. So now that we have them all up and running, possibly in a production environment, it's always important to monitor that all the services are running and performing as expected. In this section, we're going to take a look at the monitoring and observability patterns typically used in microservices. Then we will talk about how these can be implemented in a serverless world. So we'll start with the implementation of the system and application metrics and health check API patterns. Then talk about implementing the centralized logging pattern using CloudWatch logs. Then we'll discuss the implementation of the audit logging pattern in order to monitor all the activity in your AWS account. Then we'll talk about the implementation of the distributed tracing pattern using AWS X-Ray. And finally, we will talk about creating a serverless discovery and catalog service. Welcome to this video on monitoring and observability patterns. In this video, we are going to take a look at why it's really important to monitor your systems and stack. Then we'll talk about specific patterns. That is the system and application metrics, the health check API, the log aggregation, the distributed tracing, and finally the audit logging pattern. It's really important to monitor services to make sure they are running as expected and to diagnose and understand what is happening and fix or resolve any problems that you encounter. In addition, it's important to monitor performance or any bottleneck in the system. As for some businesses, this could mean loss in revenue, a data breach, or affect the reputation of the entire organization. With monolithic architecture, we have a central location for logging and monitoring, such as the application or web servers, so it's much easier to monitor. However, with microservices, there are hundreds, if not thousands of services running on their own stack, so it becomes much more difficult to actually monitor and to do any logging for each individual service or logging onto each app server, web server, for example, on each microservices is just not practical anymore. In addition, when the microservices depend on one another, such as with the API composition pattern we discussed earlier, this can lead to a cascading set of failures very, very quickly. So it's really important to catch such scenarios quickly, or better, anticipate or predict them. There are also governance, compliance, operational auditing, and risk auditing for why it's really important to monitor your services. In the open source world, for example, Prometheus service periodically polls a URL in order to retrieve some metrics. Some of the metrics could be response time, such as the latency, or look at the error rates, such as the 4xx, 5xx HTTP error codes that occur per second. We could also look at metrics such as the CPU usage, the memory, so low memory indicating, for example, that we are about to have an issue, either a slowdown or a system may crash. Disk space is also important in terms of monitoring. And this really provides a real-time reporting and metrics and data points to see if the microservices are healthy or terminating. So for example, here on the right, we have a metrics server that actually polls the metrics API of the customer support microservice and also the accounting microservice and retrieves those different data points over time. Is the system still working? We use health check endpoints in order to do this. This is where we have a periodic check to make sure that the service is still running. This can be polling the service regularly. The health check endpoint should also check that the service can be connected, for example, to the database, or run a lightweight integration test or test the query. For event sourcing and CQRS, you can also check that you can connect to the event store so that it is up and running, or submit some test event that will be ignored by all the subscribers. So if you look on the right, we have a periodic check that checks the health check API of the customer support service. That in turn will check it can connect to the local customer support data store and also connect to the event store. When you have a large number of services, it makes it impractical and even tedious to look at the web or app logs individually. It's much better to have these in one centralized location so that you can search for any issue. Logs are really useful, and having them in one place helps in debugging, troubleshooting, or any diagnosis. Having them in one place also allows you to set up alerts on triggers such as 4xx or 5xx errors or application exceptions. You can also log exception stack traces and even the full request responses. It's important to standardize the log formats in each microservice so they can be searched across one another and also filtered consistently. So typically used for the microservices in the container world are Elasticsearch, Logstash, Kibana, also known as ELK, which is a backed system for viewing logs centrally. Beats is a lightweight shipping agent to Logstash or Elasticsearch that's typically used. Logstash is a log pipeline that aggregates the service logs and writes them to Elasticsearch. So Elastic or Elasticsearch is a text search orientated NoSQL database that is used as the logging server. It can also act as a document repository where you can search free text. And typically in an open source stack is Kibana, which is the visualization tool for Elasticsearch. The audit logging pattern. So this pattern is used to record all the activity related to any actions within your infrastructure. This includes the access logs to different services. So this could be, for example, if you're creating different resources, you want to know who did that. Or if a database is deleted, you want to understand who did that. So it records all the user actions as well as the system actions. And you can also use, in order to implement this, event sourcing. So in the distributed tracing pattern, you could think about having the challenge to understand a lot of detail when you have a request. If you think about having only log entries, one at a time, it's very difficult to actually understand the full request end to end. A better way is to create a trace, which includes the full request. And again, everything is connected using what's known as a correlation ID, which is an ID that essentially is passed throughout the full request. This is something that you can trace across multiple boundaries also, for example, and helps you monitor bottlenecks and slowdowns within your request. Zipkin is a distributed tracing system that works with Kibana. It helps gather timing data needed for troubleshooting latency problems in microservices architecture. There are, of course, many others that are available.